last part of the momentum mini unit is impulse. And impulse is defined as the change in momentum. So we're going to write impulse. The letter for impulse is J, is change in momentum. So J is equal to change in momentum delta P. Now, we say that momentum is conserved, say, in a collision, meaning the total momentum doesn't change, but for each object, the momentum changes. So when one car collides into another one car ends up slowing down and losing momentum, the other car ends up speeding up and gaining momentum, and so they each have an impulse on them. Now, in order to change momentum, we have to change speed. In order to change speed, we're accelerating it, we need a force. So we can put this together, and we can say J equals delta P is M delta V is F T. So when we're going to solve one of these impulse problems, I might be given M and V and ask for impulse. Then we would do M delta V equals J. I might be given force and time and asked to find change in momentum. So we do Ft equals delta P. So you just choose two parts of the equation. Set equal to each other. So we have a couple examples down here. What impulse and force are necessary to speed up a 20 kilogram car from rest to a speed of 4 in 0.5 seconds? So we're looking for impulse. So we're looking for J. We're eventually going to be looking for force as well. We have mass here. We have an initial velocity of rest and a velocity of force. So we'll write those down. V0 is 0, V is 4, M is 20, and T is 0.5. So if I'm trying to find impulse first, I'm going to do J equals, and now I'm going to use this part of the equation, M delta V, because I have masses and velocities. So the mass is 20 kilograms times our delta V. We're going from 0 to 4, so 4 meters per second, and that would give me 80. And impulse doesn't have its own unit, so we can get it by multiplying kilograms times meters per second. Now, the second thing it wants is the force. So now that I know J, I can set J here equal to Ft and use that to find the force. So J equals Ft, 80 equals F times 0.5, and then that would give me F equals 160 newtons. So these are fairly straightforward. You just have to remember this equation and then remember to pick two parts and set them equal to each other. Now, a 0.2 kilogram egg is thrown at a wall with a velocity of 10. It comes to a stop in 0.05 seconds. The second egg is thrown at a pillow and comes to rest in 0.5. We want to compare the impulses, momentums, and forces for each of the two eggs. So we'll call this, we'll do egg 1, egg 2. All right. Their masses are both 0.2. The initial velocity of both of those is 10. They come to a stop, so their final velocity is 0. That means their change in velocity is going to be minus 10. Now, the time for the first egg is shorter because when it hits a wall, it stops really quickly, so 0.05 seconds. And the time for this one is 0.5 seconds. All right. And we want to find the change in momentum, the impulse, and forces on each of them. So we'll start with this. J is M delta V. So M is 0.2 times delta V is minus 10. It gives me minus 2 kilograms meters per second for this one. For this one, J is m delta V. It's 0.2 times minus 10, and that also gives me 2. Minus 2. So the J impulses are equal. By changing momentum, delta P, the easiest way to do this is if we look up here at our equation, impulse is equal to change in momentum, so I don't really have to do anything. Delta P equals J is minus 2. Delta P equals J is minus 2. So the change in momentum are equal as well. All right. Now the last thing it wants is force, so we could do delta P is Ft. So that gives me minus 2 is F for this one times 0.05. So then F is equal to minus 40 newtons. And over here, we will do delta P is Ft. So minus 2 is F times 0.5 seconds. And that gives me F is minus 4 newtons. Okay? So the forces are different. The egg that stops quickly has a larger force. So in slowing it down more gradually with the pillow, we're reducing the force. Another example of this is an airbag. Okay? What an airbag does is it increases the time it takes to stop. Okay? If you're in a car and the car hits a tree, the car is going to stop. You can either get stopped by your airbag or stopped by the steering wheel. The airbag takes time to collapse, so it increases the amount of time, therefore decreasing the force.